The purpose of this lab is to figure out the limiting reactant within copper 2 sulfate and potassium hydroxide by investigating the amount of precipitate formed. For background knowledge, it is important to understand stoichiometry. The website below helped us understand that stoichiometry is the study of a quantitative relationship among reactants and products. Another important term you need to know is limiting reactant, which is a reactant in a chemical reaction that limits the amount of a product that can be formed. After the limiting reactant is used up, the reaction will stop and new products will be produced, and an excessive reactant will be present. All this information was gathered from the website below. A great example of a limiting reactant can be understood in an analogy of the process of making a cheese sandwich. You need 2 breads and 1 cheese so you can make 1 cheese sandwich. And if you only have 6 breads and 2 cheese, you can only make 2 cheese sandwiches and you will have 2 breads left over due to the insufficient amount of cheese. Because of the insufficient amount of cheese, it stops you from making 3 cheese sandwiches, which can be produced if you had 1 more cheese.
The materials we use for this lab is copper sulfate, potassium hydroxide, a burette, a spatula, metric ruler, beaker, and graduated cylinder. The burette holds copper 2 sulfate and potassium hydroxide separately to prevent a reaction from occurring. The burette is measured in milliliters, 0 to 50 top to bottom. To use the burette, you add the solution measurements that you want and subtract it from how much the burette can hold. Our method of performing this lab is by using the solutions copper 2 sulfate and potassium hydroxide. Using a burette, we place 5 milliliters of copper 2 sulfate constantly in every test tube. For potassium hydroxide, we used 1 milliliter in the first test tube and added a milliliter progressing in every test tube after that by using the burette. Once the solutions were stirred together with the spatula, we waited 10 to 15 minutes to see the precipitate. Using a metric ruler in milliliters, we found the height of the precipitate in each test tube that helped us graph and calculate our data.
Now let's talk about our results. After we let the test tube sit for 15 minutes, we observed that each test tube had a top clear layer and a bottom layer of blue precipitate. Also, our data on the graph shows us that the precipitate started at a low amount, then increased as you go to test tube 4. Then it started to level off from test tube 5, 6, 7, and 8.
Now going to the data, by looking at the graph, you can see that the participant starts at a low amount, then increases as you go to test tubes 4, and then after it starts to level off from test tubes 5 through 8. In our experiment, our group put different amounts of potassium hydroxide and copper sulfate and then watched it for 10 minutes. Then our group observed the results and recorded the data of participant levels to conclude the limiting reactants for test tubes 1 through 4 was potassium hydroxide, and copper sulfate is the limiting reactant for test tubes 6 through 8. Test tubes 1 through 8 have the same amount of copper sulfate but different amounts of potassium hydroxide. So based on the graph we created, you can see that you can use the test tubes 1 through 4 have low participant, which shows that as the amount of potassium hydroxide is increased, the amount of participant levels increase, which also gives us evidence that potassium hydroxide is a limiting reactant for test tubes 1 through 4. And also, based on our data, we can say that copper sulfate is a limiting reactant for test tubes 6 through 8 because the amount of potassium hydroxide is increased and the participant will level out. Now looking at test tube 5, we can predict that there is no limiting reactant because both solutions are equally distributed to test tube 5. An error can be reading the burette incorrectly and adding more milliliters than necessary. In order to fix it, you could be more precise when adding the measurements.